Now, standard deviation. What the standard deviation tells us is how far the values from the average. How far the values from the average. If I do an experiment the right way, my results should have a normal distribution. Meaning what? If I plot the values, they should look like this. It looks like a bell shape. That's what my result looks like. This is the average, the mean. And how far are these dots from the mean? That's the standard deviation. The smaller the number, if the standard deviation is a small value. By the way, for the standard deviation, if it's a sample, we use the letter S. If it's a population, we use sigma. Looks like 6 sideways. Since almost everything in life is really a sample, it's difficult to get the population. We'll talk about both of these, but we're going to be more focused on the sample in this class than the population. And I'm going to give you some facts about the standard deviation. We'll prove that later. You're going to find out that 68% of the values usually land within one standard deviation. "95% of the values land within 2 standard deviation. And 99.7% of the values land within 3 standard deviation. So you guys good with math? I'm sure we can figure these percentage. If this is the average, the mean, the average, 68% of the values within 1 standard deviation. So let's assume we're dealing with a sample here. We'll call it x bar. That's the mean. So 1 standard deviation, that's x bar plus s, 1s. And this is x bar minus 1s within 1 standard deviation. We have 68% of the people lands between these 2 numbers. This is the mean. That means 34% of the values to the left of it and 34% of the values to the right of it. Between this number and that number. Between this and that. They have to make 68% of the values. 95% of the values within 2 standard deviations. So this is 2 standard deviation. X bar minus 2s. X bar plus 2s. 98% of the values between this dotted line and this dotted line. So if this is 68, what's 95 minus 68? That's 27. Divide that by 2 because each one is a half. 13.5% of the people will be between 1 standard to 2 standard, and 13.5% is right here. It's symmetric. And 99% of the people within 3 standard deviation. 99.7. So 99.7 minus the 95, 4.7 divided by 2, approximately 2.4% of the people in this group and 2.4% in that group. There's always less than 0.1% here and 0.1% here. 68% within 1 standard deviation, 95. So an example makes sense here. Let's take one. Let's say on the last quiz I gave you, I came back and says, not bad, guys. What's the matter? Well, the average on that quiz was a 72. And the standard deviation for that quiz was a 7. I'm just making some numbers here. And let's say the class size, we have 100 students taking this class. We know we don't have that. So what does that mean? Picture-wise, here's what it means. This is the class average. That's a 72. 68% of the people within 1 standard deviation. Let's add 1 standard deviation to 72. What's 72 plus 7? 79. What's 72 minus 7? 65, right? That means right there, 68% of the class score within these numbers. How many students? 68 of 100 students. 68 students here scored between 79 and 65. Now, 99% of the students or the class scored between what values? 2 standard deviation. That's 95 students out of the 100 scored between, let's add 7 to this, which is what? 86. Take 7 from that, which is what? 58. And almost the entire class, 99.7, that's the whole class. Almost the whole class scored within what? Add 7 to this, 93. Take 7, which is what? 51. So the bulk of the numbers, well, all the numbers between 51 and 93. Bless you. Nobody got below 50 on this test. Nobody really got above 93 on this test. Maybe there's one person on either side of it. But that's where the numbers are coming from. The numbers spread all over. Now, if I take the same problem, but instead of having standard deviation of 7, change it to a 2. So imagine if you said, you know what? I took that test. I didn't think it was that bad. I scored 80 on that test. Your score is 80. 80, you were right here. So not bad, 80, but when you look at the percentage, you're right here. The 80 is right here, right? So What is that? There's 2.5, 13.5 below you, 34% below you, 34, maybe 5 more here. So what's 2.5 and 13.5? That's for 16. 16 and 68 is what? 78? 84. And maybe 2 or 3 more, 87. You're in the top 87% of the class. Now, but what about if I change that so you are top somewhere around 87% of the class? On the other hand, let's say your score was still an 80, same class, 100 students. X bar is 72, same as before. S, the standard deviation, is 2, and your score is 80. You are probably the best student in that class in this case, the number one. Nobody got higher than you. If this is 72, 68% of the people within 2 standard deviation between 74 and 70. That's 68 students. 95 students between what? 76 and 68. And the entire class, almost the whole class, 99.7, let's say 99 plus, within what? 78 and what? 66. So notice everyone really almost the same score. So when the standard deviation is very small, that tells you all the numbers are around the average. Everyone gets almost the same score. When the standard deviation is big, the number is spread all over. So in this case, if you get an 80, you're right here. There's nobody below you. You're the top student in the class. That's where the 80 is. So just looking at the average, you go 72, I got an 80, no big deal. 72, I got an 80, no big deal. It doesn't tell you much till you look at the standard deviation. See, oh, what am I in the class? Some teachers, their exams are brutal. And when you get a 50, 56, you think you failed in the course, and you have an AA minus. I can tell you, my daughter Yale, when her exam last semester, she got a 48. She wanted to drop the course. I said, go talk to the teacher. She goes, everyone was like, she called me bawling her eyes. I bombed the test. So when they came out with the scale, Yale does that. They send you the scale after. If you score above this and that, that's what your grade. She was an A minus in that test. Half her friend already dropped the course. They were around the same score. They figured, hey, I can't afford to fail the class. They didn't wait for the scale to come out. So some teachers, their exams are tough, and you think 50. Well, in relation to what? What was the average? Where is the 10%? Where is the 15? Some schools will grade them that way. These are my A's, A minuses, B's, C's, C minuses, D's, D minuses, and F's. So it depends on the standard deviation. That will change your score. Between 66 and 68 here, you're getting actually, if this is A, for example, A minus, B, or B plus, B, B minus, C plus, C, and let's say this is D. If you score below 66, you get a D. Between 66 and 68, that's a C. 68 to 70, that's a C plus. Compare it to someone who does this. Same thing, A plus, well, there's no A plus, A minus, B plus, B minus, C plus, C minus, D plus, and D. Here, if you get between 72 and 74, you got a B. Here, between 72, let's say you got a 73. 73 here is what? A B? What is 73 here? B minus. If you get an 80 here, that's an A. If you get an 80 here, what are you getting? B plus. There's a lot of colleges, they go percentage. I want 10% of the people in the class, the top 10% to get an A. They don't care what your average is. So they make the exams extremely difficult, so you can't go, but I got a 95 average, how come I got a B? They make them tough, where the top 10% is A, the next 20% is B, or A minuses, the next group is B plus, 15%, and they do it that way. They make the exam such that the standard deviation is very actually small, that if you get an 80, you're hoping for a B minus, and you're doing great. Oh, I got an A in the course. Woo-hoo. You're not going to complain. You know. So how do we calculate the standard deviation? So that's the significance of the standard deviation. How far are the points from the average? Again, where you want it to be small. If I'm designing covers for the markers I'm using, I want the standard deviation to be almost zero. Why? Because that means all the covers will be the same size. They'll fit. If the standard deviation is big, this will fit. The next cover is going to look like this. I try to put this on, it doesn't fit, doesn't stay. So I want the standard deviation to be small. That means all the pieces are going to fit perfect. Only few of them going to be too big, few too small. We melt them and redo them again. If the standard deviation is big, you're sending back 60% of the stuff to redo. You're wasting your time. So how do we calculate the standard deviation? So that's the significance. I just want to explain what that is. Again, if it's a sample, we calculate the standard deviation for a sample to be the square root of the summation of x minus x bar squared divided by n minus 1. If it is a population, the standard deviation is the summation of x minus the average, we use mu for the average, squared divided by n, not n minus 1, by n. As I said, in real life, a lot of times we're dealing with 90% of the time, 95 is samples. So we are going to be focusing on a sample standard deviation. So let's take a few values and see if we can calculate the standard deviation. A table will be a good way. Let's assume we have these numbers. We said, can you tell us how many inches of snow we got in the last 2 weeks? And you go 0, 1 inch, 0, 3 inches. What was that big day we got? What? 18 inches in Wilbraham. Then next day we got about 3 more inches. Then we got nothing. Then yesterday we got about an inch. Today 3 inches. Tomorrow 4 inches. On Sunday it's going to be 8 inches, and so forth. Now, just looking at these numbers, do you think the standard deviation is going to be big or small? I think it's going to be more big than small. The reason, look at the values, they spread. They're not really all around each other. With the exception of these two numbers, they are close to each other, but these two numbers push them apart. If I didn't have these numbers, my standard deviation would be small, maybe 1 point something. So how do we calculate that? I'm going to make a table for that. I'm going to make my life easy. X, I'll call these the values x, and I'll make a table. Here's the 0, 1, 0. Doesn't matter if I put them in order or not. 3, 18, 3, 0, I'll move it up shortly. 1, 3, 4, and 8. And again, let me write the equation I'm going to be using. So you'll see it. S equals the square root of the summation of x minus x bar squared over n minus 1. The first thing I need to do is count how many values do we have. What is n here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We got n equals 11. I need to find what the average is, x bar. Well, how do you find what the average? Good. From last class, the average x bar is the sum of all the x values divided by n. My n is 11, so let me add them. 0, 1, plus 0, that's 1, that's 4, 22, 25, 26, 29, 33. 33 and 8 is what? 41? Forty-one divided by 11. 3.72727. It repeats. So now the next column is going to be x minus x bar. This one says take x, subtract from it x bar, and after you finish with that, square them. 0 minus 3.7273. I'll just round it up. I'll use 4 digits. That's negative 3.7273. Then square that number. 18.893. 1 minus 3.7273. Huh?
18? That's less than 4 squared. I'm missing something. 0 minus.
Oh, yes. 4 squared is 16.
Yeah, it should be 13.8.
Oh, 13? Yeah. $13.893. Thank you. The next number, 1 minus 3.7273. Negative 2.7273. Again, that's less than 3. If I square it, should be less than 9. 7.438. That's good. The 0 is the same number. I like when this is the same thing. I'll go to the zeros. I see the 1. I'll just put in what we know. Now let's take the 3. I got 3 of them. That's good. 3 minus 3.7273. That's a negative 0.7273. Now square that. 0.529. 0.529. 0.529. 18 minus 3.7273. 14.2727. Square that. 203.710. 2 more values. 4 minus 3.7273 0.2727. Square that. 0.074. 8 minus 3.7273. 4.2727. Square that. 256. So this is my n. Oh, sorry. Sum of x, not n. N is 11. I already wrote it down. I need that to calculate the average. If I add these numbers, guess what the sum is? Always going to be 0. If we do this right and you add them, this number is always 0. Has to be. Because you want to be the middle there. You're subtracting the average from it. Whatever above the average should equal whatever below the average. Now I got to add these numbers. When I add them, this is the sum of x minus x bar squared. That's the top of that fraction. So I got to go to the calculator, go 18.256 plus 0.074 plus 0.529 plus 7.438 plus 13.893 plus 0.529 plus 203.710 plus 0.529 plus 13.893 plus 7.438 plus 13.893 equals. That number is 280.182. $280.182. Now, what is the standard deviation? It is the square root of 280.182 divided by 11 minus 1. 11 minus 1 is what? 10. So it's the square root of 28.0182. Take the square root of that number. Oh, clear. $5.29. Yes.
Where did the 10 come from?
N minus 1.
Where's the n though?
Count how many values you have there, Nick.
Oh, okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 values.
Oh,
So 11 minus the 1, that's where the 10 number. Okay. Yep. This number here, the 28.0182, it has a name in statistics. Anyone? It's called the variance. This is the standard deviation. That's the variance. So that 28 s squared, which is 28.0182, without the square root, is called the variance. So if you hear the word variance in stat, that's really what that means, is before you take the square root. The standard deviation is the square root of s squared. And that's your standard deviation. Now, a lot of people hate doing it this way. They said this is the long way of doing it. Why is that the long way? Notice my table. 3 columns. I could have done that with 2 columns. There's a shortcut to that. And the shortcut says, instead of using this equation, instead of using the standard deviation to be the summation of x minus x bar squared divided by n minus 1, I got an easier one, shortcut. That says, use this one. Now when you look at it, it does not look like anything like a shortcut. N times the summation of x squared minus the summation of x, the whole thing squared, divided by n times n minus 1. That's what most people use. They go, oh, that's quicker, shortcut. And I know you're looking at it, go, come on. What do you mean shortcut? So let's take the values and do the same thing. I'll take the same values, x here's my column. I'm done with the table instead of this one. 0, 1, 0, 3, 18, 3, 0, 1, 3, 4, and 8. And I already added them from before. The sum of that was 41, right? The sum here is 41. That's the sum of x. That's the same as before. I had to add them before to get the average. I had to. I didn't have a choice. Also, what made this horrible is I had to find the average, which was some stupid number, decimal value, and I got to subtract and get these numbers here. This method, so you don't need that. We know how many values do we have. N equals what here? 11. Let's look at that equation and see what do we have so far. Just from what I have on the right there. N equals 11 in that sum. I know n is 11 times. I don't know what the answer to that is. Minus. Do I know what the sum of x is? 41. Square it. Divided by what? 11 times 10. Just by adding these and counting how many values you have, we have everything we need except one number. Yep, x squared. So now let's get x squared and add them. And I don't have to subtract anything. What is 0 squared? 0. 1 squared. 1. 0 squared. 0. 3 squared. 9. 18 is a big number. 18 squared. 324. 9. 0. 1. 9. 16. And 8 squared is what? 64. And I came up with an answer of 433. That's it. No decimal, no crazy numbers. This number here is the summation of x squared. And this one goes right here. Now I have everything that I need. Done. Let's see what the top number is going to be equal to. What the bottom number is what? 11 times 10 is that what? This one? What about the top number? 11 times 433 minus 41 squared. 3082. Divided by 110. That's amazing. 28.019. What was it before?
28.0182.
0.0182. That's because of my rounding, because I rounded that number. Again, my variance here equals 28.019, and my standard deviation we take the square root of that number. Actually, I wrote it wrong here. Look at this number. 28.0182. Can you see it if you round it? Same exact number. Same exact number. 28.01, I don't know why I said 9, 182. If you round that number. Take the square root of that number. And what was it? 5.29. Same exact answer. So why am I going to kill myself trying to subtract the average and round and carry 5 decimal places when I don't have to? So you're going to see, yes, most of the time, 90% of the time, that's the method we're going to use. Except when you have a frequency table. If you have a frequency table, we get a little problem. Notice I wrote the 0 multiple times, the 3's multiple times, the 1's multiple times. It looks silly to do that. So let's take another example. And let's say we did a study. We asked people, how many siblings do you have? And we got these numbers. X is the number of siblings. Let's even do them in ranges. How about that? We'll do them in ranges. Zero to 2 sibling. The frequency was 10 people. It says I have between 0 and 2 siblings. 3 to 5. We have what? 12 people. Let me extend this a little bit. 6 to 8. We got 18 people. A lot of siblings here. 9 to 11. 5. And Kate plus 8. What's that? She has 16 or 8? No, who has 16? Someone has 16 kids. 19 counting. 19 counting. Yeah, something like that. 9 and 3, we're not going to count them here. 9 and 3 is 12. 11 and 3 is what? 11 and 3, 14. Let's say we have 1. And we want to calculate the standard deviation for them. Now, if you want a copy of these equations, I'm just looking to see if I have them for you on the website. If you click on class notes, it says formula sheet. And if you click on that formula sheet, wait 2 seconds and that equation will show up. Under chapter 3, it says, to find the standard deviation when you have frequency distribution table, we're going to use this, n times the summation of f times x squared minus the summation of f times x, the whole thing squared, divided by n times n minus 1. When I started this problem, I was thinking of sibling how many you have, 0, 1, 2, 3, and just do it single value, but I opted to do it with range of value. So this is actually the range, not x, because we have no idea how many they have, the range of values. Between 0 to 2, 3 to 5, 6 to 8, 9 to 12, 12 to 14. So my x value for these is going to be different. What am I going to use for the first group there? What should we use for a value? How many siblings they have?
1.
Why 1?
It's in the middle.
Yep, the midpoint. For 0 and 2, the midpoint is what? Add them and divide by 2. That's a 1. The midpoint, 5 and 3, 8. Divided by 2, 4. The midpoint, 8 and 6, 14. Divided by 3 is 7. The midpoint, 20. 20 divided by 2 is 10. The midpoint, 26 divided by 2, 13. If you look at this equation, I need two columns. I need one that has f times x, and I need one that has f times x squared. Now, before I continue with this, how many people took this study? Participate in the survey? Can we figure out what that is?
Yeah, the sum of f.
Sum of f. If you add the frequency, that's how many people? 12 and 18 is what? 30, 40, 46? That's your n. N equals 46. So now, let me plug in what I know so far before I do anything. The bottom is going to be 46 times 45. The top is going to be 46 times, I need a number, minus another number squared. I got to get these numbers. This one says take f multiplied by x. 10 times 1. 10. 12 times 4. 48. 7 times 18. Big number. 126. 5 times 10. 50. 1 times 13 is 13. And when you add them, that's 247. 247. This one is the sum of f times x. So I know the answer to this, 247. I'm missing this piece. This one says what? F times x squared. So I got to square x and multiply it by f. Well, to do that, we all good in math here. Hopefully you completed Tech Math 1 and 2. If you take x and you multiply it by f times x, what are you going to have? I'm talking about algebra. X times f times x. Fx squared, right? So just take these two columns, multiply them out. That's a quicker way to get the answer. 10, 4 times 48, 192, 7 times 126, 882. 10 times 50, 500. 13 times 13, 169. And the result is 1753. That's the summation of f times x squared. That's this number right here. Now take your calculator, multiply these numbers out, take the square root of that. 46 times 1753 minus 247 squared. 19629. The bottom, 46 times 45, 2070. The square root of 19629 divided by 2070, 9.48. Take the square root of that. In 3.08. So the standard deviation for this, 3.08. Again, we're very interested in the standard deviation for a few reasons. In life, when you're designing something, you want to make sure your values land within 2 standard deviations, on the plus and the minus. When you're flying in a plane, the width of that seat on the plane is designed to hold people between 2 standard deviation plus or minus. That's 95% of the people. The height of the door is 80 inches to satisfy 2 standard deviation. The government says you need to make sure you cover 95% of the population. You do that, you're going to be okay. Now, 95. Actually, when you do that, you're covering more than 95, because the height of that, if you're a little person, if we make the door 80 inches, it doesn't affect you. Only affect the basketball players. The guys 7'3", 7'4", when they come in, they can't. They're going to duck. So that's, the 5% is actually the bottom half and the upper half. The bottom half is not going to have a problem with it. So when you do 2 standard deviation, you're only really affecting that percent there, this group, the 2.4% for the door height. The same thing with the width of that seat on the plane. If we make it this one, if somebody gets on the plane that's skinny, they might be bouncing all over, but they'll be happy. They got tons of space there. Only the bigger one's going to have a little issue, that 2.4%. So by making them within 2 standard deviation, you are covered. So we call these values usual and unusual values. As long as you are within 2 standard deviation, you are an usual value. Once you go outside, that's unusual. Quickly here. So the minimum is called usual value. That's a term we use in statistics. So the minimum usual value, if you hear that, usual, it is actually the mean minus 2 times the standard deviation. That's the minimum usual value. The maximum usual value is going to be the mean plus 2 times the standard deviation. So if you land within 2 standard deviation, either direction, that's considered a usual value. a lot of times we don't have the data there. Few months ago, we all panicked about that Ebola break, and we don't have enough information on the Ebola. But let's say we know that one of them was sick. The longest period of somebody staying sick with that is 28 days. Bless you. We're not talking about the ones died from it. And the shortest period, some people are only affected for as short as 3 days. We don't have everyone information. All we know is what we call the range. The range is the highest value minus the lowest value. So the range here for being infected by Ebola is what? 25 days, the range. We don't have the data, so we have nowhere to apply this equation to calculate what the standard deviation is. We don't have the information. Where is it? We don't know what x is. We don't know what the average. So what do we do then? In this case, we use what we call approximations, called the rule of thumb. The standard deviation becomes approximately the range divided by 4. So in this case, 25 divided by 4. 6 times 4 is 24. What's that, 6.25? That's called the rule of thumb. Again, we apply that when we have no data. We just have the range of it. So when you go and buy a bag of chips, the bag of chips that should weigh this much, it should, or a sleeve of cookies, it should have that many cookies in it. As long as the number of, let's assume, for example, it's supposed to have 24 cookies, that's the average. And the standard deviation is 2. This is the mean. So can we figure out here what the usual value versus unusual? The range for the usual values for a sleeve of cookies, Girl Scout cookies, supposed to be within what? 2 standard deviation. So the minimum these sleeves should have in it what? Twice the standard deviation. Standard deviation is 2. What's twice that number? 4. What's 24 minus 4? 20, and the highest value should be 24 plus 4, which is what? 28. This is the average. So the average is 24. The minimum acceptable number is 20. The maximum acceptable number is 28. I won't complain if you gave me 40, especially if they're Thin Mints. I like those. But that's really what's the acceptable value. So when they do a quick testing on these, they grab a few of these bags to see if they're below 20, knowing people are not going to complain if it's more, unless it's Weight Watcher program, then defeats the whole purpose there. But they check to see if it fits that criteria. If it's outside that, they go, you're lying to us. Same thing with the bottle of Coke. It's supposed to have 16 ounces or 12 ounces. Do you have 12 ounces in them? And they do random testing on them. So that's the minimum usual value. That's the maximum usual value for that. Okay, that's the end of it.